Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is Cambridge O-Levels Physics 5054. Today we have set our hearts to solve a paper 2, and for this purpose we have selected October-November 2010 2-2 paper. This paper 2 belongs from the Zone 2, or you can say the Variant 2. The section A of this paper I have already solved and it has been uploaded in my YouTube channel. In this video, I'm going to work on the section B of this paper. Section B will start from the question number 9. So let's start today's paper. So on your screen, the section B of 2010 October-November 2-2 paper is showing up. He says, question number 9, figure 9.1 shows a very large plane mirror inclined at 45 degrees to the horizontal beneath a pattern on the high ceiling of a hall. So here we have, this is the ceiling. Ceiling means the roof. And this is the ceiling. There is a pattern on the ceiling. Here we have put a mirror. And these are the light rays coming from that pattern. And they are striking the mirror. The mirror is at angle of 45 degrees with the horizontal. The mirror is set on a stand at head height immediately below the center C of the pattern. R and S are two rays of light from C that strike the mirror. On the figure 9.1, continue the rays R and S after they strike the mirror. So, these are the two rays, R and S. So what you will do, you will put your protector here and draw a normal. Then check how much is the angle of incidence. Then I will draw the same angle of reflection. And I will draw this line, reflected ray for the R. And I will prolong that reflected ray behind the mirror. In the same way, I will draw a normal here with the help of a protector. And I will check how much is the angle of incidence. Angle of incidence is the angle between the normal and the incident ray. And then I will draw the reflected ray in such a way that the angle of reflection is equal to the angle of incidence. That will be the reflected ray for the ray S. I will prolong that ray behind the mirror, where these two prolonged rays will intersect each other. That will be the image. So that is the question on figure 9.1. Show how these rays are used to locate the image of the C and mark and label the position of this image with the letter I. So let me show you. I have done this. Let me reduce the size. Okay, so you can see here, this is the ray R. This dotted line, that is the normal. I will check how much is this angle of incidence. I will make the same angle of reflection. This is the reflected ray for the ray R. I will prolong it behind the mirror. Same way, I will put the protector here. I will draw a normal here. I will check the angle of incidence for S. I will make the same angle of reflection, which is equal to the angle of incidence. I will draw this reflected ray for S. I will prolong it behind the mirror. So where these two rays will intersect, that will be these dotted lines behind the mirror. I prolong them in the dotted line. And where these two dotted lines intersect each other, that is the image. Okay. So this is how it is done. I can show you the marking scheme also. These are the two parts. Okay, then their question is state two characteristics of this image. State two characteristics of this image. You see, this is a plane mirror, and the image which is formed in the plane mirror, its characteristics are that the image is virtual. The image has the same size as that of the object. The distance of the image from the mirror and the distance of the object from the mirror, they are equal to each other. The image is laterally inverted. So these are the some main characteristics. You only have to write two characteristics here. For example, I have written here virtual and upright. The image will be upright. So you can see the marking scheme here. laterally inverted. Okay, so suggest how the mirror helps visitors to the hall to see the pattern on the ceiling. Okay, so when the observer is here, or observer is here, you can place the observer here, you can place the observer here. He will be able to see, you can put the observer here also. He don't have to look up. He don't have to look upward to look at this pattern at C. He only have to look straight into the mirror and he will be able to see that that pattern of the ceiling here. So you don't have to stretch your neck, strain your neck and look upward. So that is why this technique is used. No need to strain your neck to see the ceiling. That is our answer. More comfortable, no neck strain, no need to look up, reflects to eyes. Then we have the question number 9b part. He says violet light from C has a wavelength of 4 x plus minus 7 meter. Calculate the frequency of this light, clearly stating the value of any constant used in the calculation. You know the speed of the light in the vacuum or in the air is almost 3 expo 8 meter per second. You know that formula V equals to F lambda. So by using that formula, we call it the wave equation. We can find out the frequency. V is equals to F lambda. The velocity is 3 expo 8 equals to F into the lambda is wavelength 4 expo minus 7. So F will be equals to 3 expo 8 divided by 4 expo minus 7. When you do this in your calculator, you will get 7.5 expo 14 hertz. 7.5 expo 14 hertz. 7.5 expo 14 hertz is the right answer, sir. And then we have state two different components of the electromagnetic spectrum that have wavelengths smaller than the wavelength of the violet light. So here we have Ronald McDonald is very ugly except Gary. So because the violet light is in the visible light, and so the electromagnetic spectrum whose wavelength is less than the visible light are ultraviolet, X-rays, gamma rays. So I have written here ultraviolet and gamma rays. We have UV light, ultraviolet, X-rays, and gamma rays. Okay, then he says, discuss a medical application on one of these components of the electromagnetic spectrum. You see the UV light is used to kill the germs. And X-rays are used in the imaging of the bones. And X-rays are also used to kill the cancerous cells, cancer cells. And the gamma rays are also used to kill the cancer cells. Gamma rays are used to treat cancer by killing the cancer cells in cancerous tumor. So here we have, if you say UV, X-rays absorbed by bones, not absorbed by flesh. So you can make a shadow or image of the bones on a photographic film or CCD. Gamma rays emitted by absorbed isotope, position, shape of organs, etc. revealed, and tumor cancer absorbs it. For both the rays are used for this purpose. Tumor destroyed, photon energy stops cells multiplying. Bacteria absorb UV, X-rays, gamma rays, bacteria killed. Sterilization stops bacteria multiplying. So I think you can write a better answer. Gamma rays have high energy in them. So when you focus gamma rays on cancer cells, they are killed. Then we have state a health risk associated with this component of the electromagnetic spectrum. We have written about the gamma rays. The gamma rays are used to kill the cancer cells, and they can also cause the cancer. Okay, the gamma rays cause cancer and hair loss. Whenever you might have heard that whenever you have some cancer patients and their radiotherapy is done, so radiation is given to them to kill the cancer cells, so they lose their hair. They lost their hair. UV light can damage eyes, skin, cancer, X-rays, cancer, hair loss, radiation sickness, gamma rays, cancer, hair loss, radiation sickness. Okay, so we are going to the next question. That is question number 10. A bus breaks down on a road with a 10-degree upward slope. The passengers get out and push the bus to the top of the slope at a constant speed. Figure 10.1 shows the passenger exerting a force on the bus parallel to the line of the slope. So here we have that slope. They are pushing this bus upward on this slope. The angle of this slope with the horizontal is 10 degree. The total mass of the bus is 32,000 kg. Calculate the weight of the bus. If you know the mass, you can easily find out the weight. W is equals to mg. And here we go. So W is equals to mg. M is 3200 kg and the g value is 10. So 3200 multiplied 10, that will be 32,000 Newton. 32,000 Newton. And that answer is right. Okay, then we have question number 10A, second part on the figure 10.1. Draw two arrows to show the direction of the weight of the bus and the direction of the force exerted on the bus by the passengers. So the force exerted by the passengers, that is along the slope, so that force is in this way. Okay, and the weight of the bus will be acting exactly downward like this. Okay, so let me show you. Here you see the force of the passengers, that is along the slope, and this is the weight of the bus. Okay, now the next question is the total force exerted by the passengers on the bus is 17,000 Newton along the line of the slope. Use a graphical method to determine the size and direction of the resultant of this force and the weight of the bus. State the scale used. Okay, so we have to mention the scale here. We have to tell the size of the resultant force, and we have to tell the direction of the resultant force. These are two vectors. 32,000 Newton is the weight of the bus. 17,000 Newton is the force exerted by the passengers. And we have to add them up and we have to find out the resultant force. And you know, we can add two vectors by the parallelogram law. In the parallelogram law, what we do, we put both the vectors in such a way, the vectors to be added. One is 32,000 Newton and the other one is 17,000 Newton. We will put them in such a way that their tails are joined together. Graphically, we will put them together. And then we will complete the parallelogram. And where the tails are joined, we will join that point with the opposite corner, and that will give you that diagonal will be the resultant force. Okay, for example, here 17,000 Newton is the force exerted by the passengers. So I have chosen a scale. 1 centimeter will represent 4,000 Newton. So 17,000 Newton, 17,000 divided by 4,000 Newton, that will be 4.25 centimeter. So I will draw a line here, which is 4.25 centimeter long, and it is making a 10-degree angle with the horizontal. Here I will draw a line because the weight of the bus is 32,000 Newton. So I will divide 32,000 Newton with the 4,000 Newton and I will get 8 centimeter. So here I will draw a line of 8 centimeter, which will be making 90-degree angle with the horizontal. So once you have drawn these two lines, their tails are joined here. So these are the two vectors whose resultant force you want to find out. Then you will open your compass. Open your compass 4.25 centimeter. Put the needle of the compass here, draw this arc. Then open your compass 8 centimeter. Put the compass needle here and draw this arc. Where these two arcs intersect each other, join that point with this and with this. So your parallelogram is completed. Then where the tails are joined, join that vertex with the opposite vertex. And that this diagonal will represent the resultant force. With the help of the scale, measure the length of this diagonal. It will be, in our case, it is 8.3 centimeter. So I will multiply 8 because 1 centimeter represents 4,000 Newton. So I will multiply 8.3 centimeter multiply with the 4,000 and I will get 33,200 Newtons. So the size of the resultant force is 33,200 Newton. If you want to measure what is the direction of this resultant force, you can measure this angle. If you draw a horizontal line here, measure this angle of the resultant force with the horizontal, and I have measured it. This is 59 degrees. So 59 degree with the horizontal. So this is the direction of the resultant force. You can also measure the angle of the resultant force with the vertical, but you have to then write here 59-degree angle with the vertical. So this is our answer, and I hope you have learned it. You know how this is done. Okay, so this is the marking scheme, and this is how that is done. Okay, so we are done with this. Okay, so then we have question number 10, A4 part. The bus travels at a constant speed. State the size of the resultant of all the forces acting on the bus. You see, whenever an object moves with a constant speed, that shows that its acceleration is 0. And acceleration is only 0 when the resultant force is 0. So we can say that the size of the resultant force acting on the bus, all the forces acting on the bus, thus the resultant force will be 0. So the resultant force will be 0. Okay, now we are going to the next part, and it says, as the passengers push the bus up the slope, work is done against two forces. State the name of these two forces, and for each force, state the form of energy produced as the work is done. So when you go up the slope, you work against the gravitational pull of the earth, or you work against the gravitational field of the earth. So when you move against the gravitational field of the earth, your gravitational potential energy will increase. The second force against which you have to work is the friction between the tires and the road and the air resistance. So when you work against these resistive forces, your energy will convert into thermal energy. So here we go, the gravitational force, gravitational potential energy, and friction, thermal energy. That is our answers. So not gravity, this is important. Okay, now we are going to the next part, question number 10C part. When the bus reaches the top of the slope, it stops and the passengers get back in. On the axis of figure 10.2, sketch the distance time graph for the bus from a time when the passengers are pushing the bus at constant speed until they get back into the stationary bus. So here we have to draw a distance time graph. So because the speed is constant, and at the end the bus becomes stationary. When the speed is constant, it is represented on a distance time graph with an inclined line whose gradient is constant. So you will draw inclined line, straight line, I mean. The gradient will not change. And when the bus will become stationary, the line will become horizontal, which means no distance is covered after that. So here you see I have drawn a straight line. Its gradient is constant, which means the speed is constant. And here I have drawn a horizontal line, which means the gradient is zero, which means the bus is stationary. So this is the graph they are talking about. So you can see here, this is the marking scheme. Okay, then their question is state how the speed of a moving object may be obtained from any accurately drawn distance time graph. You know, the gradient of the distance time graph represents the speed. The gradient of the distance time graph represents the speed. Calculate the gradient. Okay, so we are done with the question number 10. Now we are going to the question number 11. Figure 11.1 shows a workman using a cordless electric drill. And here you see the workman is using an electric drill. It's cordless. The motor of the drill is powered by a rechargeable battery with an electromotive force EMF of 18 volt when the drill is used. The power supplied to the motor is 450 watt. Explain what is meant by an EMF of 18 volt. It means that the battery is providing 18 joules of energy to unit charge to move it around the closed circuit. Or you can say another definition is the 18 joule of chemical energy is converted into electric energy when the unit charge flows through the battery. So these are the two definitions. The battery do 18 joule work to move unit charge in a closed circuit. This is our definition. So this is the marking scheme. This is my answer. And here we go. Question number 11B part. The workman uses the drill for 90 minutes. Calculate the electric energy supplied to the motor. The electric energy is power multiplied time. The power of the electric drill is 450 watt. The time is 90 minutes. So I can calculate, if you want to calculate the electric energy in joules, then energy is power multiplied time. The power will be taken in the watts and the time will be taken in the seconds. If you want to calculate the electric energy in kilowatt hour, then the power will be converted into kilowatts and the time will be converted into hours. It's up to you, whatever you want to do. For example, here I have calculated the power, the electric energy in joules. So energy is power multiplied time. When you want to calculate the electric energy in joules, you take the power in watts and you take the time in seconds. That's why here we have put 450 multiply 90 multiply 60. We have converted the time into seconds. So when you do this, you will get 2.43 expo 6 joules. 2.43 expo 6 joule is the right answer. If you work in kilowatts, if you want in kilowatt hours, then this will be the answer. Okay, then the question is question number 11B, second part, the charge that the battery supplies. You know, I is equals to Q divided by T. So the charge is Q, I is the current, and because P is equals to IV, I will be equals to P divided by V. So in the place of I will put here P power divided by the voltage. That's 450 divided by 18 multiply the time will be taken in the seconds. Here 100% the time is taken in seconds. So 90 into 60 and you will get 1.35 expo 5 coulomb. 1.35 expo 5 coulomb is the right answer, sir. the charge is current multiplied time, and the current is power divided by voltage. These are the two different formulae which we have used. Hope you understand. He says after 90 minutes of the use, the battery is flat. It is connected to a charger and is recharged. The charger includes a transformer that produces a 23 volt AC output from a 230 volt AC main supply. Draw a label diagram to show the structure of this transformer. You see this transformer, its input voltage is 230 volt and its output voltage is only 23 volt. So it's a step down transformer. So whenever you make a step down transformer, on the primary side show more number of coils, and on the secondary coil in the secondary coil show less number of coils, because it's a step down transformer. Because here the ratio between the secondary and the primary voltage is 1/2. So if you show, let's say, 20 turns on the primary coil, then there will be 2 turns on the secondary coil. If you will say you represent 40 turns on the primary coil, then there will be only 4 turns in the secondary coil. So you have to keep this in your mind. For example, here you can see I have drawn, this is that metallic frame, and here we have the primary coil. On the primary side we have 230 volt, on the secondary side we have 23 volt. Here I have only shown 2 turns, here I have shown 20 turns. So the ratio of the secondary number of turns to the primary number of turns is 1/2. That 1/10. Sorry, I said 1/2. 1/10. So that is the same ratio between the 23 volt and the 230 volt. It's a step down transformer. I hope you understand this diagram. So that's the C part. Turn ratio should be this. Okay. They say this. Let me tell you one thing. Primary ratio secondary. It's a step down transformer. Okay, then we have state how the transformer ensures that the AC output has a value of 23 volt when input is the 230 volt AC main supply. You see how we make sure that on the primary coil, let's say if you have 20 turns, that on the secondary coil we will have only 2 turns. We make sure that the ratio of the turns is 10, means primary turns ratio secondary, that 10:1. Or if you write it more clearly in your sentence, make sure that you mention that in your ratio you are putting which quantity first. The ratio of the turns of the secondary coil to the primary coil. You see here we have written clearly that the secondary coil turns I'm writing first, then I'm writing the primary coil. Secondary coil to the primary coil, then I will say 1:10. If I say primary coil to the secondary coil, then it will be 10:1. So be very clear when you write this. Secondary turns will be 1 and the primary turns will be 10. You need to be very, very clear about this. Okay, then we have, he says, question number 11C, third part, the 230 volt AC output of the transformer is used in a rectifying circuit to produce a direct current that recharges the battery. Complete the circuit diagram of the circuit. Rectifying circuit is that you use a diode, and the diode will let the current flow only in one direction. So you have to draw a diode here, and then you have to connect it with the battery. So you see here I have connected a diode, and the diode will let the current only flow in this direction. When this alternating will try to flow in this direction, it will not let it flow. So now this diode will only let the current flow in this direction, and we have connected it with the positive terminal of the battery. So when you connect the coming current in with the positive terminal of the battery, that recharges the battery. So this is how you will draw this diagram. He says diode symbol for battery shall allow either polarity with respect to diode and complete circuit. Okay. So then we have state and explain one advantage of using an alternating current for long distance transmission of the electric power. You see, when we use alternating current in the long transmission lines, we can use transformers because the transformers will work on alternating current. And with the help of the transformers at the power station, we will increase the voltage. When with the help of the transformer, you increase the voltage, the current will decrease. And when the current decreases, the power loss in the transmission lines decreases. And when the transmission line reaches the consumer, there we put a step down transformer and we reduce that voltage. So the alternating current is used because the transformers can work on it. So transformers work on AC current. So by using a step-up transformer, voltage is increased and the current is reduced. This reduces the power loss in the transmission lines. Okay, so this is my answer, and let me show you the answer. He says can be transformed, operate, transformer voltage can be changed, high voltage, low current transmission possible, changing magnetic field, less energy, power loss, or less heating in the wires or thinner wires. You see, with the help when we use alternating current in the primary, this produces a changing magnetic field, and this induces EMF in the secondary coil. So that's why the transformer can work on alternating current. So my dear students, I hope you can write a better answer for this. You can consult your teacher also. This is our idea of the answer. I have shown you the marking scheme as well, and we are done with this. So my dear students, we have completed the section B of this paper, and we have reached the end of this paper. And today it's very hot here. You can see I am sweating. So thank you very much for taking out time and watching this video. You see, I am a humble student of physics, and I am not a scholar of that. Means I am only a humble student. So there is possibility that I might make a mistake. But you see, I always tell you that whenever you find an answer, for example, the answer is coming from my side, please confirm it with the marking scheme. Please check it with your teacher. Please confirm it from the red spot also. You see, it's possible that I might make a mistake. It's possible that when I'm writing the answers, and then I might by a mistake make a mistake. So please, it's a good habit to check the answer of your answer, your teacher's answer, your mentor's answer from the marking scheme. Thank you very much, everyone, for taking out time and watching this video. If you think that this video will help you, your friend, your class fellow, your juniors, your seniors, your teachers, please share the link of this video with your students, with your teachers, with your class fellows by posting the link of this video onto your Facebook, onto your Instagram, onto your Twitter account. When you do this, it helps me to promote my channel. It's a great blessing for me that God has given me a chance that I can make these videos and I can touch the life of so many students around the globe, and I can make their lives, their teachers' lives, their parents' life a little easier. And I can bring the solution of the past paper to your doorstep. By the click, you can find that solution. Thank you very much. Have a good day. God bless you all.